Great. So yes, like John said, my name is Beiko. I recently joined the Ethereum Foundation to facilitate the core developer calls. So these are the calls that we have amongst the different client teams working on Ethereum to make changes to the protocol. Prior to that, I spent 2.5 years working on one of those teams, so on Consensus's protocol team, so being one of the implementers there. So today I want to walk you all through the state and roadmap of Ethereum. So what are changes we've made to the protocol and what you can expect to see in the coming year or so. And after this talk, I'll be hanging out for Q&A. So at a high level, there's kind of three big things I want to cover. The first is the upgrades that have gone live over, say, the past 6 months. Then the upgrades you can expect over the next 6 or so months. And then finally, the merge, which is when we take Ethereum 1, which is the current Ethereum network that's running today, and the Beacon chain, which is the new proof of stake consensus, and merge them together in order to get rid of proof of work on Ethereum. So let's start by the Beacon chain. So the Beacon chain, for those of you who are not familiar, is the proof of stake mechanism that's used by Ethereum. Basically, this is the most complex part of the entire Ethereum 2.0 roadmap. It is a completely new consensus mechanism that basically, instead of using mining to secure the network, uses validators' stakes. And you might have heard of proof of stake before, and a lot of other blockchains, say that they have proof of stake. And the major difference with Ethereum and why it took so long to launch is that Ethereum's proof of stake consensus is much more heavily decentralized. So one big challenge you see with proof of stake consensus algorithms is they end up centralizing around a small number of validators on the network, and people will delegate their coins to those. Ethereum has, from the start, wanted to keep participation as open as possible in the network. And that required a ton of just technical overhead and research in order to be able to manage all of these different validators. And over the past few months, we've actually managed to get this live. So last year, around mid-October, so October 14th exactly, the Beacon Chain deposit contract went live on Ethereum. And what this deposit contract does is allows anybody with an Ethereum address on the current network to deposit Ether in order to become a validator in the Beacon Chain. And then before we actually activated the Beacon Chain, we wanted to make sure there was a minimum amount of Ether raised in order for the chain to be secure and to avoid any attacks on it. So that minimum amount of Ether was 524,000 and something Ether, so not dollars, but units of Ether. And between basically October 14th and November 24th, we raised this amount. So we had this total amount of deposit in the contract. And then once it hit that threshold, there was a 7-day countdown before the Beacon chain would actually go live so that client teams could actually prepare and get their releases ready and whatnot. Oh, sorry. And then today, these numbers are actually from today. I updated them just before this presentation. The Beacon chain has over $10 billion securing it and about 120,000 validators. So this is 1 or 2 orders of magnitude more than any other proof of stake system. And it might be the largest proof of stake, the largest dollar amount also on a proof of stake system. So it took a while, but we finally have this running. It's up there, and there's billions of dollars securing it, and it's been working kind of flawlessly for over a quarter now. In parallel to that, on the Ethereum mainnet, we had an upgrade just last week called Berlin. So this upgrade brought in a few different features. The 2 most important are EIP 2929 and EIP 2718. So this first one, EIP 2929, basically raised a lot of gas prices for opcodes which access the state on Ethereum. And the panelist right before me was mentioning that as you have more and more people using Ethereum, state growth actually makes nodes harder to run on the network. And so this gas cost increase was necessary so that as there's more and more state, each item of state actually gets harder to access because the state is stored in a trie, and so the trie becomes deeper, and every time you want to access an item in the state, you need to go down the entire trie. So we had to raise the gas prices of these opcodes so that the time that they take to actually execute by a node is proportional to what they cost in terms of Ether. And this imbalance that we had prior to EIP 2929, where these state accessing opcodes were relatively too cheap compared to how much computational resource they use, was one of the largest denial of service risks on the Ethereum mainnet, because somebody could just build a bunch of transactions who just touch a bunch of state, and then they would underpay relative to the computational load they put on the network. So luckily, this has been addressed now with 2929. And one thing that also we could not do prior to this was raising the gas limit. So this week we've seen the gas limit starting to raise a little bit because we now feel a bit more confident that opcodes are priced well. The other big change that came to mainnet with Berlin is EIP 2718, which introduces the concept of transaction envelopes. And what these envelopes are is just a wrapper around transactions, which enable you to introduce many more transaction types to Ethereum. So before Berlin, we basically only had two types of transactions. So we had the EIP 155 transactions, which are the common transactions used today, and the pre-EIP 155 transactions, which were done before the DAO hard fork and had issues with replay attacks. So we've basically like hard coded these two types of transactions on the network. But there's been over the years a lot of proposals to add more types of transactions to give application developers more flexibility. And so 2718 is kind of the stepping stone to get there, where we just have this general concept of a transaction envelope, and now it's easier to add new types of transactions. And then alongside that, we basically added the first new type of transaction to Ethereum, which was done in 2930. And what this allows you to do is, if you want to get slightly lower gas costs for state accessing transactions, you can specify in advance which part of the state your transaction will touch, so that this way the node that's processing it can prefetch that state, and it helps a bit with execution. So this was meant to prevent contracts breaking by introducing EIP 2929. So even though it's not the best practice to hard code gas prices and smart contracts for specific transfers and whatnot, people always do it. So every time gas prices are raised on mainnet, it leads to smart contracts breaking. So EIP 2930 is a way that we can tell basically developers, if you have a smart contract that's broken because of these new gas price, you can just send this special type of transaction, specify in advance which parts of the Ethereum state you want to touch, and you'll be able to use lower gas prices, and that means your contract will still be accessible. And then finally, we had one more small change coming into Berlin, which was EIP 2565. And this basically repriced a precompile that was priced too expensive relative to its execution time. So we just lowered the price of that one so people can use or make more calls to it for the same amount of gas. So these are the two upgrades we've seen happen over the past year on Ethereum, and we have two more that are coming shortly. The first is called Altair, and this is the Beacon Chain's first network upgrade. So basically, there's three things that will be added. The first is adding what's called sync committees, which are validator committees that need to provide specific data every time they attest in order to help light client support. So we're basically going to add a little bit of duty onto validators, which will enable light clients for the Beacon Chain to be built much more efficiently. The second is basically an accounting reform. So right now, in order to keep the Beacon Chain efficient, we don't compute the validator rewards as soon as they come. So we kind of wait until there's a lot of rewards to compute, and then kind of do one run of all the computation. And this incentive accounting reform will basically add some more efficiency to how we compute those validator rewards. And the last one is increasing the penalties. So when the beacon chain was launched last year, we specifically reduced the penalties for either being offline or making a mistake and getting slashed, because the beacon chain was new and experimental, and we wanted to encourage people to come on it and stake. Now that it's been up for a quarter and it's going quite smoothly, we're raising the penalties back to what their original levels were supposed to be. So that means that if you are offline, you get a small penalty when you kind of miss your turn, or if you produce a conflicting vote, then you'll get a much larger penalty, and you'll be removed from the validator set. And we feel that the beacon chain is mature enough now that we can basically play by the production rules. So that's the first update coming for the beacon chain, and it'll be the first time we actually do the update on the live system. So it'll be kind of a good way to test drive the upgrade mechanism on the beacon chain with something that's not too complex technically. And then again, on the Ethereum mainnet side, we have another upgrade called London that's going to come this summer as well. We're still in the planning stage of this, so we basically have half of it settled, and then we're still discussing a few other ETHs. But other things that are included for sure, the main one that's coming to London is EIP 1559. You might have heard about this before, but it's a major change to how the fee market on Ethereum works. It's been worked on by different client teams for over 2 years. And the goal there is really to improve the UX for transaction senders and to improve the economics of Ethereum as a whole. This is kind of a huge topic worthy of its own presentation. I encourage you to look into it if you're interested in just how the UX improves based on it, or the economic changes that it brings. But I'll leave it at this for now, and happy to answer any questions about 1559 in the Q&A afterwards. The other change that's included is EIP 3238, which will delay the difficulty bomb for another roughly 9 months. Basically, Ethereum has what we call a difficulty bomb as part of the proof of work mechanism, where over time, the proof of work gets exponentially harder, or gets an exponentially harder difficulty. So for most of the time, because it's an exponential curve, it's basically flat. But at some point, it goes up quite quickly. And the goal of this feature is to force the chain to move over to proof of stake, so that miners cannot just stay on the old chain, because at some point it'll become completely unmineable. Because we're not quite ready yet, we're pushing it back a little bit. It doesn't mean that we can't have the merge before the summer of 2022. And it doesn't mean that if something went wrong, we couldn't push it back again. But it gives us this mechanism for when we decide we do want to do the merge, then it kind of puts an end of life on the proof of work chain. And then the last ETH that's included in the London upgrade is EIP 3198. This adds a base fee opcode, which is a component of 1559. And the base fee is basically the minimum price you'll need to pay for your transaction to be included in a certain block. So adding an opcode that returns that makes it very useful for smart contracts who want to programmatically have their transactions be included in blocks. So those 3 are going in for sure. Now there's 3 more that we've been discussing a lot, and hopefully we'll come to a resolution on in the next couple weeks. The first is EIP 3403, and this would remove the gas refunds from the S-Store and self-destruct opcodes, except in a few edge cases. And the main motivation for that is that actually, it's twofold. So one is that gas refunds provide an incentive to store a bunch of gas when gas prices are cheap, and then get a refund for it when gas prices are high. So we've seen things on mainnet called gas token and chi token, and this contributes a lot to the state bloat of the network, because basically as soon as gas prices drop, people start minting these gas tokens and kind of hoarding them so that they spend them when the gas prices are high again. And then the second challenge with refunds is that they actually end up making blocks larger than we would like them. So right now, if you look on mainnet, the block limit is 50 million gas, but refunds are deducted by that. So deducted from that. So it means that you could effectively run a 30 million gas block where you run, 15 million gas worth of execution, and then you get it all refunded. And the act of refunding all of that will basically double the execution time of your block. So it's kind of this weird gotcha that we have in how gas execution works. And so if we remove the bulk of the refunds, we can just have higher certainty about what the execution time of an average block is. The other EAP that's being discussed is EIP 3074. This would introduce two new opcodes, auth and auth-call, which would give contract the rights to invoke transactions on the behalf of a wallet owner. And this could provide basically a bunch of whole new use cases like paying for gas for your users, doing what we call meta transactions, and easier kind of constructs for building multi-sigs and whatnot. So it's quite interesting from the dApp development perspective, but we're still analyzing the security implications of it. And then lastly, an EAP that's being considered is EIP 2537. This adds a new cryptographic curve as a precompile, so the BLS 12381 curve, which is the same curve as the beacon chain. So it's something we want to have around when we merge Ethereum 1 with Ethereum 2, because it'll allow Ethereum 1 to verify information from the beacon chain natively. So again, this is London, and then it should be live on the Ethereum network sometime around July or August. We're still, again, finalizing the details here. So with all that being said, the big thing to keep an eye out over the next 12 months is the merge. So at a high level, the merge is taking our current Ethereum network and changing the consensus algorithm to the proof of stake beacon chain. And this is something that everybody wants to see happen, that client teams on both the beacon chain and the Ethereum mainnet side are working on. So it's going to become kind of the main focus over the next year. And it's worth kind of highlighting how we got to this. So over the past 12 months, there's been a lot of iteration on the Ethereum 2.0 roadmap. Originally, we had this roadmap where we wanted to ship proof of stake, then we wanted to ship different shards for Ethereum, and then have a bunch of different execution environments. And as we researched that, the execution environment part of it, so phase 2, was becoming by far the most complicated part of it, and it wasn't sure how ready it would be. Well, at the same time, there was a lot of progress made on rollups as a way to scale Ethereum. And so there was this idea that instead of focusing on execution environments and having different types of shards, to scale Ethereum, we could instead use rollups to be the main avenue by which we scale Ethereum. And what's interesting with rollups is that they work directly on a single EVM shard, but they can also leverage data shards. So shards that don't process computation, but just store data in order to store the data that they would otherwise store on mainnet. So by moving to a rollup centric roadmap, we can greatly reduce kind of the complexity of rolling out Ethereum 2.0 and still get some massive scalability improvements by having people use rollups instead of execution shards. And so that was kind of a big shift in the roadmap. And then once that was roughly agreed upon by the community, one more change was to say that instead of then having the EVM run in a shard separate from the beacon chain, we could couple those two things together and have the EVM basically run inside the beacon chain to greatly simplify the overhead of the two communicating. And this would be closer to basically changing from a proof of work model to, say, a proof of authority chain that we can have in private networks, rather than having a whole new client architecture. So we can leverage basically how clients are somewhat used to dealing with different consensus mechanisms and treat basically the proof of stake chain as the new consensus mechanism for the EVM chain. And this is what everyone is focused on right now. And so in order to prototype this, we started a hackathon called Realism. Here's a picture of Realist art, to try to get different client teams to prototype what would the minimal version of a merge client using both Ethereum 1 and Ethereum 2 look like. And this is ongoing right now. We expect to have it done around mid-May. And that already inform us about how how do these clients look, what's needed, and what are the engineering things we need to figure out over the past year. And I think this is my last slide. Yes. The open questions we have with regards to the merge are as follows. First, what's the transition mechanism we want to use? So how exactly do we want to define the switch from proof of work to proof of stake? And what are the security assumptions around that block, given that miners might not want this change to happen? Second, what does the client architecture look like? Do we want to allow many-to-many connections between clients so that you could use eea-eth or parity and then take Coup or Prism and mix and match any one of them as you want? Or do we want tighter integrations? Lastly, the beacon chain and the Ethereum mainnet have quite different assumptions with regard to historical data. So right now, the Ethereum mainnet tends to conserve historical data kind of by default, whereas the beacon chain tends to prune anything past the finality period, more or less by default. So thinking through how we reconcile those two kind of data models and what the right defaults are for the post-merge chain is a really big topic. And then obviously, with an engineering effort of this size, there's 1,000 technical details we need to figure out. So both to get prototype working, to set up the merge, and then all of the cleanup and refactors we'll need to do afterwards. If you want to get involved, this is actually my last slide now. If you want to get involved, Realism is the hackathon I mentioned. So if you want to help build the prototypes or just test them out, you can see it there. There's bi-weekly merge calls happening where the core developers go through all the open issues and progress updates. We have a Discord for all of the R&D on Ethereum. So if you really want to be in the weeds of it and see what's happening on a daily basis, this is the best place. And finally, ETH Research and Ethereum Magicians are the two forums we use to discuss kind of higher level technical and non-technical ideas around new features for the merge, the implications, the roadmap, and whatnot. And that's all I had. Thank you so much for your time.